In this video, I'm going to talk about the data representation inside the computer. Computer use binary numbers, and we are human beings, we use decimal numbers. For binary numbers, you have 0, 1 as basic digits. So in this section, we're going to talk about binary numbers and binary addition, integer storage, hexadecimal number systems, and signed numbers and unsigned numbers, and character storage. Binary numbers, 1 or 0, each of these is called a bit. 1 means true, 0 means false. And this is a binary number. This binary number has 16 digits. The rightmost digit is called the least significant bit, and we call it LSB. The leftmost digit is called the most significant bit. Each of these bit has a location value or position value. It's like the index. So the first rightmost bit is called location 0. And the last one is location 15. So this is a binary number with 16 bits. Binary number. This example has 8 bits. 8 bits is a byte. A byte is the smallest storage unit for a computer. So it's a group of 8 bits. For this binary number, we have 1, 1, 1, 1 in each position. For a binary number, each this position has a position value. For the first number, rightmost digit, the position value is 2 to the 0th power. The second digit is 2 to the first power, then 2 to the second power. The last one is 2 to the 7th power. You can see each of these position value will double the previous one. So this one is 1, 2, 4, 8, 16, 32, 64, 128. So remember, we are going to use this position value to calculate the values for a binary number. So this gives a shortcut for the values we are using here. 2 to the 7th power means 128. 2 to the 6th power is 64. Is a quick reference table. This is a formula. How to find out the value for a decimal number in decimal. And D stands for the binary digit. So each of this is a D, the binary digit. Use the binary digit 2 times the location value. Add a second digit with location value, and you can find out the value for a binary. That's the decimal equivalent for a binary. Let's take a look of this binary example. This is a binary number with a bit, 8 bits is a byte. This one equals decimal 9. To use this formula to find out it equals 9, we need to use D times the location value. The first D, this is 0. 0, the first one is 0 times 2 to the 7th power, so this goes to 0. The second D is 0, that means 0 times 2 to the 6th power. This is all 0. So this 0, 0, 0, 0. So your first 4 terms here will be 0 until you reach this one. So this one d is 1. Use d times 2 to the third power. This is the position value, 2 to the third power, because the index here is 3. And this will give you 2 zeros for these 2 terms anywhere somewhere here. The last one give you 1 times 2 to the 0th power. 2 to the 0th power means 1. So add up this, we're going to have 9. This is 8, this is 1, total will be 9. So this binary number is a representation of our decimal number 9. Translating unsigned decimal to binary. Unsigned number means 0 or a positive number. Our example is 37. To convert 37 to binary, you need to keep dividing by 2. You start 37 divided by 2. You have the quotient 18, the remainder 1. In step 2, you continue use 18 divided by 2. You get a quotient 9, you get remainder 0. So 9 divided by 2, you get the integer quotient 4, remainder 1. 4 divided by 2, you get a quotient 2, no remainder. You use 2 divided by 2, and your integer quotient is 1, no remainder. Then finally, you use 1 divided by 2, and you have no quotient, but you have 1 as the remainder. So whenever you have quotient reached 0, this is how you stop there. So your answer is about the remainders. So 37 equals 100101. So you make sure you write the answer up. So start 1 goes to here. This one is here. So if you watch my video link in the learning activities section, you will see there are some other ways to do it. There are shortcuts to get the answer quickly. I don't want to talk about it here. Binary addition. You want to add up 2 binary number, and let's see how. So first is binary 4, because this is 2 to the second power. So this is decimal 4. This is decimal 7, because 1 plus 2 plus 4. You should have decimal 7. If you add 4 plus 7, your answer should be 11. And this is 11 representation. Let's take a look. You have 1 plus 2 plus 8, and this should be 11. That's right. So to do binary addition, you just add digits to digit in the same location. 0 plus 1 is 1, so you put 1 here. 0 plus 1 is 1. 1 plus 1 is 2. In binary number system, you can only use 0, 1. So 2 means 1, 0. To write 1, 0, you put 1 carry to the next digit and put 0 down. 1 plus 1 is 2. 2 means 1, 0 in binary. And here, 1 plus 1 is 2. 2 means 1 here, 0 here. Oh no, I made a mistake on this step. This is 0 plus 0 plus 1, so your answer should be 1. So 4 plus 7 is 11, and the binary corresponding part, and you should have 11 also. Integer storage size inside your computer. Computer use byte, word, double word, quarter word for storage. The smallest storage unit for integer is 8 bits. That's called a byte. 2 bytes for integer storage is called a word, 16 bits. And double word storage means 32 bits, that's 4 bytes. Quad word is 64 bits, and that's 8 bytes. For unsigned byte, that means positive or zero or positive numbers. If the largest number you can put into a byte, use a byte 8 bits for storage is from 0 to 255. This is the equivalent part. That means 2 to the 8th power minus 1 means 255. If you use a word for storage, the largest number you can put or save into a word is 0 to 65,535. It equals to 2 to the 16th power minus 1. This one. This one. Same logic, you can find out you want to save a positive number inside a double word, that means 32 bits. The largest number you can put is this much. That's 2 to the 32th power minus 1. For a quad word, you can store this much. Here we have a challenging question. If you want to save a positive number, unsigned positive number, using only 20 bits, what's the largest number you can have if you use 20 bits for storage? The answer is 2 to the 20th power minus 1, because based on our observation here, and we can say the answer should be 2 to the 20th power minus 1. That's the largest number you can put into 20 bits. Hexadecimal number is a different number system. People use hexadecimal to do the shortcut for binary. Binary numbers, some can be very long, hard to read. So we give a shortcut by using hexadecimal number. Let's take a look at this table. We have binary 0, decimal 0, hexadecimal 0. We have binary 1, 0, 1. So we have their equivalence. For decimal 7 in binary is 0, 1, 1, 1. Same thing in hexadecimal is 7. For number 8 in binary is 1, 0, 0, 0. Hexadecimal is 8. For 9, binary is 1, 0, 0, 1. The hexadecimal is 9. For decimal 10, in binary it should be 1, 0, 1, 0, because this is 2. 2 plus 8 is 10. And in hexadecimal 10, we don't use 10, we say letter A. Use letter A to represent the decimal 10. For decimal 11, in binary is 1011, 1011. And we use B to represent the 11 in decimal. And so we continue for number 12. Binary is 1100, and we use C for decimal 12 in hexadecimal. Number 13 is 1101 in binary, and we use D in hexadecimal. And number 14 in hexadecimal is E, and we use 1110 for 14, because this is 2 plus 4 plus 8, that's 14. 15 is F in hexadecimal, and binary is 1111, because this is 1 plus 2 plus 4 plus 8. Total should be 15. Translating binary to hexadecimal. This is a very long binary, I guess. 24 bits long. To translate a binary into hexadecimal, you group each 4 bits together, then write the corresponding hexadecimal part. So 0100 is 4 bits in a group, you copy here. Another group is here, 1001, and continue and list all these each 4 bits in a group. So this is our starting binary number. We copied this to here. Then we're going to find out the hexadecimal on the top. 0100. This is 4 because this is 1 location, 2 location, this is 4 location, so this is 4. This is hexadecimal 9 because this is 1 plus 8, so there should be 9. This is 7, 1 plus 2 plus 4, so it's 7. This is 2 plus 8 is 10. In hexadecimal, we use letter A. And this is 6 in hexadecimal is 6. And this is 1 and is 1 in hexadecimal. Converting hexadecimal to decimal, you need to use digit multiply the location value by the index power. We have 2 examples here. The first hexadecimal is 1, 2, 3, 4. To find out how much it is in decimal, we're going to use first digit, that's D. That first D is 1, multiply 16. The index is 3, so it's to the 3rd power. And second D is 2. 2 multiply 16 to the 2nd part because this is a location 2. This is 3 times 16 to the 1st part because the location value here is 1. And 4 is the D. The D is 4 times 16 to the 0 because 0 is the index for this position. And if you use your calculator, you find out the answer should be decimal 4,660. Second example, use D3 times 16 to the 3rd power. B is 11. B means 11. So we use 11 times 16 to the 2nd power. And we use A is 10. So we use 10 times 16 to the 1st power. And 4 times 16 to the 0th power is 15,268. So hexadecimal number is the power of 16 system. Each position in the hexadecimal number will be 16 times more than the previous digit. So this is a quick table for 16th power. 16th third power is 4,096. Converting a decimal to hexadecimal, we divide the decimal by 16. So 422 divided by 16, the quotient is 26. The remainder is 6. Then we continue 26 divided by 16, and our quotient part is 1, and the remainder is 10. 10 means 8. And finally, you use 1 divided by 16. You don't have a quotient integer, that's 0, but you have remainder 1 here. So your answer should be 186 for hexadecimal. 186. 186. Adding hexadecimal. 6a plus 4b. A plus b. This is 10. 10 plus 11, that's 21. For 21, You want to convert into hexadecimal. That's quotient 1 and remainder 5. So that's you put a quotient over here and you remainder over here. This one stands for 16. So we add up this line, and this is 11, that's B. Let's take a look at the second example. 8 plus 8 is 16. 16 in hexadecimal means 1, 0. And this is 8. 8 plus 5, this is 13. 13 means D in hexadecimal. Then we have 6. And this is the same. So we have 4 examples here. Subtracting hexadecimal numbers. 75 hexadecimal minus 47 in hexadecimal. 5 minus 7. 5 less than 7. We have to borrow 1 from second position. Borrow 1 from second position means you borrow 16. So you borrow 16 plus 5, that means you have 21. So you have 21 minus 7, you should have E. E means 14. Okay. So you borrow 16, add with what you have, that's 5, that's 21, 21 minus 7, you have 14 left over, that's E. So 7 minus 1 minus 4, you have 2 left over. 6 minus 2, that's 4. And we have C minus A. C is 12. 12 minus A, 10, that's 2. Okay, next video I'm going to talk about how to deal with signed integers. Thank you for watching.